So today we are going to discuss pull force. So in case of pull, what will be? Suppose we have, with the help of a rope, you are pulling something. Any object is there, and with the help of rope you are pulling. Then in that case we are applying force. Again, it is inclined to horizontal. It is not horizontal. So the force will be applied in this direction. External force will be in that direction. Suppose this angle is theta. Gravity is acting downward, normal reaction is acting upward, friction is acting in this direction. Fs or Fms or Fs, simply F, whatever you want, give the symbol, you can give, no problem. Or simply less. Then what will be, if you break this component, one will be this F cos theta and F sin theta will be this side. So in this case, we are getting this N plus F sin theta is equal to mg. We are getting small m there, so here also small m we can take. That means in this case, normal reaction is mg minus F sin theta. In that case, normal reaction was mg plus F sin theta. And here it is mg minus F sin theta. Naturally, normal reaction is less. Normal reaction less means friction will be less, because friction is directly proportional to normal reaction. As we have not changed the nature of the surface, so coefficient of friction will be same. So as friction is less, that means in order to start motion, we have to apply less force. That is the, if you are asked in reasoning type question, you will have to explain like that way, that normal reaction here is this much. Normal reaction in that case was mg plus F sin theta, but here normal reaction is mg minus F sin theta. So normal reaction will be less in case of pull, and hence friction will be less. So we have to apply less force in order to start motion. That's why the pull is easier than push. So this friction will be how much? Mu s times N mu s mg minus F sin theta. So this F cos theta must be equal to this F friction in order to start motion. So to start motion, what is the condition? This F cos theta must be equal to Fs or F. Are you present?
Yes, sir.
Are you able to see the code? What I wrote just now?
Below 2 stat, it is not visible, sir.
Then
It is
you
not
didn't say
coming.
anything. Intensely, I am writing that like that, and no one is saying anything. I don't know. So f cos theta is equal to f. That means this f cos theta is mu s times mg minus f sine theta. So when you will solve, taking this f sine theta this side, we will take common. Then cos theta plus mu s sine theta will come. So same expression will be, but here positive sign will come. So in this case, the force required will be mu s times mg by cos theta plus mu s sine theta. Here in the denominator it is cos theta minus, but here it is cos theta plus. Naturally, this value will be less than this. Sometimes we are asked to derive the expression for push and pull, and hence you prove pull is easier than push. Then you have to derive this relation. Means in both the cases, you have to write what is the friction, what is the normal reaction, what is the friction, how much external force is required. Here also, what is normal reaction, what is friction, and how much external force is required. Then we are comparing these two. Now, what is the minimum force required? So here we are free, we can change the angle also. If you want to push this one, pull this one, we can change the angle. So by changing the angle, what will be the suitable angle where force is minimum? So for maximum or minimum, what is the condition we are knowing? Here we are changing the angle. Maybe for 5 degree, because here it's coming cos theta plus mu sin theta. And with increase in theta, what is happening? Cos theta will decrease, whereas sin theta will increase. So there will be a particular value for which this cos theta plus mu sin theta is minimum. And sorry, maximum. And in that case, f will be minimum. So we are going to find what is that value of theta. At what angle we should apply the force so that by applying minimum force we can pull the object. So for minimum pull force, df by d theta should be 0. If we differentiate it with theta, it will come 0. Have we done differentiation? No. So when you differentiate this, then you will understand differentiation, then you will do. So in that case, it is coming, the condition we have to learn that tan theta will come mu s. That is same as angle of repose or angle of friction. So if we are applying the force at that particular angle, then minimum pull force will be required. So in that case, what will be value of cos theta and sin theta? We can find if tan theta is this much. What is cos theta? Tan theta is mu s. Sin theta is how much? Tan theta means P by B. Sin theta, sorry, tan theta is P by B. Sin theta is P by H, perpendicular by hypotenuse. So it will become 1 by, no, mu s by 1 plus mu s square under root. And cos theta will become 1 by 1 plus mu s square under root. If you substitute this value here, what will you get? What will be the minimum force? F minimum will become mu s mg by cos theta 1 plus mu s square under root mu s by 1 plus mu s square under root. E by B, yeah. Base by hypotenuse B 1 plus mu s square sin theta is this much. Correct now? Here mu s is also there. So mu s square will come. Sin theta is this much. Mu s is already here. Okay. So how much will come? So mu s mg 1 plus mu s square under root by 1 plus mu s square. Naturally, this one will become, if we are squaring this is coming. So it will come mu s mg by 1 plus mu s square under root. So this is the minimum force. So minimum force required to pull the object. And for that, theta will be tan inverse mu s. So when the force is applied at this much angle, that is angle of repose or angle of friction, then we can pull the object by applying minimum force, and this will be the minimum force. Now we discuss motion. Motion of an object on rough. First is horizontal surface. So what will be the motion of the object on?
Sir, upper part is not visible.
Now, so motion of an object on rough horizontal surface. If surface is horizontal but it is not smooth, then suppose this is rough surface. This is the object which is moving with acceleration A on this surface under the action of this external force F. We have applied a force F. So if we make a free body diagram of this object, what will be? The weight of the object will act downward, normal reaction will act upward. As it is moving, so it will be kinetic friction. So kinetic friction is acting along this direction. So Fk. So once object starts moving, we will have to consider kinetic friction. In order to start motion, how much force is required? Then limiting friction. And both the coefficient are slightly different. Kinetic friction will be slightly less than limiting friction. If simply coefficient of friction is written, you are free. That means both are almost same. Sometimes you will be given static friction is this much, kinetic friction is this much. Then when the object is moving, we have to use kinetic friction. Coefficient of kinetic friction. Okay. So this Fk is how much? This is mu k times n. So this is your free body diagram. So what will be the equation? So this F minus Fk will be equal to Ma. This Fn means mu k times mg, because n is equal to mg. So we got the relation, this F minus mu k mg will be equal to m. This is the equation. If you are asked to find acceleration, then this by this divide by m. If you are asked to find what is the external force, this will go that side. So this is our equation of motion. Whatever is asked, we can make that one subject. If suppose the object is moving with constant velocity, then what will be? The object is moving with constant velocity or uniform speed. With uniform velocity. The same velocity it is, direction is also not changing. So if velocity is uniform, in that case what will come? So A will be 0. In that case, A will become 0. So this external force will be mu k times mg. So in order to maintain the motion, this much force is required. In order to start motion, mu s mg is required, which is more than this. In order to maintain the motion, mu k mg is required, which is less than limiting friction. So to start motion, what will be? This F must be more than or equal to mu s mg. In that case, external force will be more than limiting friction. Then only, or just equal to limiting friction, we can say. Limiting friction is 100, and if we are applying 100.00000001, then also it will start. This is rough horizontal surface. Now, rough inclined surface. So now it is rough inclined surface. Surface is inclined, then what will be? Well, how we discussed the motion. So there are two types of motion here. The object may move upward or object may move downward. So two situations will come. So first will be suppose upward motion we are discussing. So we are applying force F in this direction, and object is moving with acceleration A in upward motion. Well, this angle is theta. Now, what are the forces? Same concept, free body diagram one. What we have done in Newton's law of motion, that chapter. Same concept. Only one additional force will be here, friction will come. So this weight of the object is acting downward as it is moving upward. So friction you can apply here or you can apply there, no problem. This is Fk. This is normal reaction. So as particle is moving along the plane, so one axis will be along the plane, other axis you have to consider perpendicular to the plane. Naturally, this weight is not along any axis, so we'll have to break it into component. So if this is theta, this will be theta. So one component, this is mg cos theta, and this side will become mg sin theta. Now, what will be the equation here, or what will be the, and it is not moving in this direction, neither moving along the plane, this normal direction or this side, component of the weight. So this N will be here equal to mg cos theta. Fk, which is equal to mu k times N, will be mu k mg cos theta. Yes? Coming. So, what will be the equation of motion? This F minus Fk must be equal to ma. No. Here, this side, two forces are there. So, two forces are opposing that. So, Fk plus mg sin theta. This is the opposing force. This will be equal to ma. This is the equation. Now, whatever is asked, if you have to find A, we'll find A. If you are asked F, we'll find F. So, this is your equation of motion for upward motion. Here also, if A is 0, then this is the case. If particle is moving with uniform speed, uniform velocity, this K will become 0, and in that case this F will be equal to F. In place of F, K, what will write? One will not be there. So what will be here? So this F is mu K mg cos theta. Equal to mg you can take common. So this equation will be what? F minus mg we can take common. Then mu K cos theta minus sin theta plus sin theta. Plus sin theta will be yes. So that will be the equation, final one. Now we come to this side, that is when acceleration is 0.
Sir, time is up.
But wait for 1 second. So this A is 0, then what will be? This F will become mg will take common mu K cos theta plus sin theta. So this will be the force when acceleration is 0. That is if the object is moving upward with uniform velocity. Okay, so we'll leave up to here. Wait for the attendance.